Hey there, my name is Dan Friedman, and I'm a data center solutions engineer at Cisco. Happy New Year to anybody who's watching. Today is January 5th, and I want to spend some time kicking off the new year by talking about Cisco Nexus Smart Switches. I think this is going to be a key technology for us this year. Along with Hypershield integration, as you'll hear about during the presentation. So I've been following a format of presentations for the last several that I've been posting up on YouTube, and this is no different. So the key messaging bullet points that you see on this slide are basically going to be the slide headers for the rest of the content in the deck. So you can use that as a sort of table of contents for finding the information that you're looking for once you're done watching the video. If you need to get back to it, I'll also provide that in the YouTube comments so you can navigate to the video section easily. We also have key value proposition points, which we'll talk through briefly on this slide. And actually, I've got a slide at the very end of the deck that we'll use to kind of wrap up the discussion that talks about key value proposition points. So to start with, what are Cisco Nexus Smart Switches? And if I were to put it as simply as possible, I would call them high performance, centrally managed, distributed segmentation devices. Okay, we'll talk about what all that means in specifics as we get into the presentation. For key value proposition, these are points that we're going to wind up talking through as we go through the deck, but I'll just quickly read through them here. Integrated network and security with DPUs, that'll become very clear. High performance and scalability, that will become very clear. Advanced security with Hypershield, so we're going to talk about the integration with Hypershield, what that looks like, what some of the features are. Programmability and automation, and actually there's a section under key messaging where we talk about that specifically. And then cost efficiency and simplified architecture. So we're going to talk about our management tools and how you can save money using the solution. And then it's a future-ready platform. We're going to talk through all of these points as we get into the presentation. So let's go ahead and get started. Now, before we get into the key messaging portion of the presentation, I do want to spend a minute talking about why we need smart switches in the first place. And this slide does a good job of capturing that. We've got a really high rate of new vulnerabilities discovered every day, and AI is only making that problem worse. Those vulnerabilities are then weaponized against our customers within 24 hours before customers are even aware that there's a problem. And we all know that getting access to the first machine in the data center is just the tip of the iceberg. Hackers are then going to attempt to move laterally within the data center to compromise additional machines. And all of this results in a high cost to the customer in terms of business reputation, regulatory exposure, and repair. The problems that we're trying to shore up with a smart switch are those in the bubble labeled defense gap on this slide. We want to reduce the number of blind spots that you have in your environment. So we're going to talk about exactly what we mean by that later in the presentation when we talk about the different layers or enforcement points that are part of the solution. And we also want to reduce the amount of time it takes customers to protect themselves. We all know that the initial breach is bad, but the lateral movement makes it far worse or can make it even catastrophic for the company, right? The perimeter is a speed bump on the way to your internal network. It's necessary, all customers have it, but without internal network segmentation, the road inside the data center is wide open. And AI accelerates exploits, and time inside your environment amplifies the damage. So rapid detection, response, and updated policy enforcement are a must. All right, so let's quickly talk about what we mean by unified networking and security. The key concepts to understand here are as follows. Number one, old switches have a general purpose NPU, network processing unit, or CPU, that handles traffic, routing, switching, forwarding, etc. Smart switches are layer 3 capable, and they include an additional AMD Pensando DPU to handle security policy enforcement, okay, and provide telemetry as well. Two, customers can purchase Smart Switch today with the DPU disabled and enable the DPU later. This future proofs their environment for another 5 to 7 years, which is the typical length of a hardware refresh cycle. Three, DPUs are programmable chips, meaning that their capabilities are going to be enhanced and expanded upon over time. And four, Smart Switch is part of the Hypershield, quote, security everywhere architecture. So we're going to talk about that coming up in a couple of slides. As you can see, I highlighted here the N9300 Smart Switch, and over on the right, the primary use case that we're targeting today is to position these as top of rack switches. There are going to be additional use cases. We'll get into that towards the end of the presentation. Here is a quick visual of what I was just talking about. So on the left, you'll see the NPU, which is the Cisco Silicon One ASIC, and that's what provides the rich set of NXOS features and services. And on the right, you'll see the DPU, the AMD Pensando DPU with the security services that it provides. Today, we're focused on the distributed security or layer 4 segmentation features that I've highlighted in the yellow box. But in the future, we will be adding additional security features that you see here in the lower right portion of the slide. I don't have specific roadmap timelines for those features yet. That's all being worked on or worked out currently, but at least some of these features are currently expected to start showing up in calendar year 26. I've captured functionalities in the upper right corner that are currently out of scope for your reference. Now, high throughput and flexible port configurations are part of what's available in these hardware switches. This is a pretty simple and easy slide. High throughput means that you're going to get 800 gig line rate throughput on either of the switches that you see here, delivered by the Silicon One E100 4.8T ASIC. Both devices have a 16 core Intel CPU and an AMD Pensando DPU with 128 gigs of DPU memory. The switch on the left is the 48 port 25 gig switch, which supports breakout configurations on the higher bandwidth ports. And the switch on the right is the 24 port 100 gig switch, which supports breakout configurations on all the ports. Both of the switches support the top of rack segmentation use case, which you can see down at the bottom in light blue, but the 100 gig switch will support additional use cases in the future, and we'll talk through those towards the end of the presentation. All right, let's talk about AI-driven security with Hypershield. First, I want to give you a high-level view of where Hypershield fits into our security portfolio. So on the left in yellow, you will see major trust boundaries. This is what we mean when we typically talk about perimeter firewalls. To address this, you have Cisco's traditional firewall portfolio or third-party firewalls. On the right in yellow, you will see distributed everywhere east-west. This is what we mean when we talk about lateral movement within the data center. This is internal traffic. To address this, you will have Cisco smart switches at the network layer and eBPF software agents at the host layer, and potentially additional enforcement point at the super NIC at the NIC layer. All of this is going to be managed via Cisco Secure Cloud Control, which is a SaaS-based management platform that is a wrapper or umbrella hosting security tools for the entire security portfolio. So that's Hypershield at a high level. Next, let's dive into some of the details around Hypershield's multi-layer security architecture. There's kind of a lot going on in this slide. We're going to spend some time here, so I'll try and make sure that this becomes clear by the time we're done. Hypershield is a new distributed security policy enforcement architecture with centralized management. If you're using security cloud control, and we'll get into the details on that in just a minute. Okay, so the components of this architecture are one, security cloud control, as I mentioned. This is the SaaS-based centralized policy management and visibility platform, but it's not fully ready yet. The Hypershield component of it is not fully ready yet. It's not actually, well, it's shown in the upper right corner of this slide, security cloud control. Okay, then number two component would be the network layer. So what do we mean by that? This is the smart switch with the DPU specifically. The DPU integrates security software within the network hardware. And this is what's going to provide layer 4 segmentation capabilities, controlling and reducing lateral movement within the data center. So I'm going to use my mouse here real quick, and I'm going to put it in the blue area so you can see it. This first blue box that we see up here at the top represents the Nexus 9300 smart switches at top of rack, okay? So we're showing them here in a spine leaf architecture running NXOS software. And if we, this line that you see over here on the left is meant to go all the way through the network switches and match the network that you see over on the right. We'll get there. Okay, so that is what I'm referring to when I talk about the network layer. And the green dots that you see here are essentially the DPUs within those switches. Okay, the next layer is what would connect. Well, I'll go down to the host layer first, right? So down here, you see eBPF agents. So this is software running on a host and protecting modern applications like container-based apps or VM-based applications. It doesn't really matter. Over here on the left, you can see the host type can be bare metal, it can be virtual machine, it can be container. And in terms of host software running on any of those types of hosts, if the host is running Linux operating system, we have the software agent support for that today. If the host type is running Windows operating system, we will have the software agent for that in the future. And it could be that for technical reasons or political reasons or whatever, you are unable or unwanting to run a software agent on your hosts, in which case you will have agentless hosts. Okay, so we support all different kinds of hosts, and the goal in an ideal scenario means that you're going to run a software agent on the host. And I'm going to explain in a minute why that would be, why that's important, why that's an ideal scenario. Okay. Now, what connects the host to the network? Obviously, that's the NIC, okay? And today, we don't have this as a security policy enforcement point like we do in the network DPU or on the software agent running on the host. But it could be in the future that this becomes an additional point of policy enforcement, giving us multiple layers with which to protect our workloads, okay? So, so this is the network layer, again, shown here. This is the NIC layer, so I'm sort of trying to show that this is the NIC connecting to the network from the host down here, goes all the way through, and then this is the host layer down here, okay? The network, NIC, and host layers all provide telemetry or visibility and points for security policy enforcement, but only the host layer provides kernel level visibility and control. And I should say today, the NIC doesn't actually provide a security policy enforcement point, only the network and the host today. But again, in the future, the NIC may also be an additional point of enforcement. Okay, only the host layer provides kernel level visibility and control. So what does that mean? Okay, on a host, on a per process basis, you can see and control which other processes a particular process is allowed to talk to. You can control reading and writing data to a disk. You can control reading and writing data to the network. So this is a level of security control and visibility that we've never had before. It's all going to be configurable within security cloud control with appropriate policy deployed at the desired enforcement points. So again, the layers allow you to apply policy the way that you need it. Do you need to protect a specific workload? Fine. Push kernel level policies to the eBPF software agent running on that workload. Do you need to protect all workloads on a specific host? This would be an example of when you would want to push layer 4 policies to the super NIC DPU as an enforcement point. Okay, that's future. Do you need to protect all workloads on multiple hosts? This is an example of when you'd want to push layer 4 policies to the smart switch DPU, or in the case shown on the right, where it shows agentless in light blue, those guys don't have any software agents running on them, so there is no policy enforcement point on them. In that case, you would want to push layer 4 segmentation policy to the upstream network. Okay, so the closer you get to the workload, the more granular your security policy can be. But that being said, if you can't do anything, you're still better off enforcing policy at the network layer to prevent that lateral movement within the data center. The larger concept is that ideally, again, customers are going to deploy these eBPF software agents on their hosts. To repeat myself, Linux is available today. Windows will be available in the future. As shown on the right on this slide, this will provide kernel level telemetry up to Hypershield SaaS, right, which is running either in the on-prem controller or security cloud control. We'll talk a little bit more about what that architecture, the cloud control and the on-prem controller looks like coming up in some future slides. And that telemetry is going to be not just from the workload, but additional telemetry also collected from the network and the NIC layers. So with that comprehensive visibility, Hypershield is then going to be able to make both layer 4 segmentation and kernel level policy recommendations. Those policy recommendations, which are AI driven, can be tested via dual data plane technology, and that enables customers to test policy against copies of real production traffic for a range of time. And once confidence is gained and policy is approved, then it will finally be deployed to the appropriate enforcement points in production, including back to the eBPF software agents. So as you can kind of see in this diagram in the upper right corner, right, you can see at the network layer, the enforcement point is the DPU and the switch. At the NIC layer, the enforcement point would be the DPU and the NIC, that's in the future. And at the host layer, or workload layer, the enforcement point is the software agent that's running on that workload. Okay, so all of those things provide telemetry up to Hypershield, and then policy is the result of that, and that gets pushed back down to the same points on the network, the NIC, and the host for enforcement. So it creates a closed loop whereby the hosts and network inform Hypershield of what it sees, with those same devices ultimately receiving back the proper policy to enforce from Hypershield. This architecture enables us to secure any kind of workload, whether it's VM-based or container-based or bare metal, at one or multiple layers. Okay, nobody else is doing this. For customers who buy into this concept and this architecture, they're the ones who are going to be interested in purchasing Smart Switch with DPU disabled for now, only disabled because Hypershield is not fully ready. Okay, it should be ready next quarter. We're also recommending that customers purchase in Q2 or Q3 of fiscal year 26, which basically gives us from now until the end of April, because we have a really great promotion running now that makes these switches super affordable, and it's not guaranteed to continue. So we're going to cover that promotion towards the end of the presentation. Next, let's get into some details on the hardware a little bit. As you can see on the left side of the slide, we have two models of switches available now, both of which are capable of 800 gig line rate throughput. We have a 24 port 100 gig switch on the top, and we have a 48 port 25 gig switch on the bottom. depending on what your customer's connectivity needs are. And remember, both of these switches support the top of rack segmentation and enforcement use case that we've been discussing. From a hardware constraint perspective, I've captured that on the lower left. Today, we don't have port side exhaust versions of these switches, but those are going to be coming available in April of calendar year 26. So by the end of Q3. No ZR optics are supported because they generate too much heat for the switch to be able to handle adequately. Okay, so we won't be supporting those optics in the switch. Now, the use case that we're targeting today is top of rack switching, and this is based on customer feedback, but other use cases have been mentioned in past presentations on Smart Switch. There was the change in focus on use case, and there was also a change with regards to the on-prem controller, which we haven't discussed yet, but those changes have led to a shift in architecture and use case focus. Okay. The other use cases that were mentioned in the past were zone-based firewalling, data center interconnect, and cloud on-ramp. We are going to revisit those in the future. As you can see here, Cloud Edge, which is cloud on-ramp, and zone-based segmentation are currently slated for April calendar year 26, which I'm showing in the lower right. But for now, the focus is still top of rack, okay, for this first through the end of Q3. So these switches are based on the Silicon One ASIC, which is a programmable high performance chip. And a frequent question that we get is whether or not Smart Switch can be used as an ACI leaf switch. And the answer is no, because Silicon One switches cannot be managed by the APIC. The business unit is considering a cloud scale version of Smart Switch, which can be managed by the APIC, but this is not committed as of now. Um, Silicon One is newer than Cloud Scale, so number one, it's a lot of effort to move everything from Silicon One to Cloud Scale support, and number two, Cloud Scale is an older technology, so that's why it's not yet committed. It's still being evaluated, collecting feedback from customers, etc., at the BU level. However, these switches could be attached to an ACI leaf via the Nexus One VXLAN EVPN strategy that we already have today, and then they can still be leveraged as a layer 3 inline device, still capable of performing the function that they were designed for. Okay, so if you really want to use it as a firewall, you can still attach it to an existing ACI leaf switch, but it would not replace that leaf switch. Okay, we take things one step further and we use the same eBPF software agent approach that we use to protect our workloads to also protect the network that all of those workloads are running on top of. In short, NXOS runs atop a Linux kernel, which means we can run the software agent in the kernel and use it to control and protect the network operating system itself. The reason this is important is to be able to quickly detect via telemetry and protect via policy against zero-day exploits that might impact an XOS operating system. This means you can, quote, plug the hole, which would give a hacker access to the NXOS vulnerability without actually updating, modifying, or patching the NXOS operating system in a maintenance window. What that means is you can be protected now while conducting your upgrade during the next scheduled maintenance window rather than scheduling a new maintenance window to do due to a security event. And really, there's this time lapse that happens between exploit or vulnerability discovery and availability of a patch in the operating system anyway, right? So we want to be able to provide immediate protection of the underlying network and buy customers time to patch the network, but without compromising on security. Finally, let's talk about the management components, which is where operational simplicity and cost savings are key concepts. So from an operational standpoint, we will have separate tools and workflows for net operations and sec operations teams. From a network operations perspective, we're managing network infrastructure and traffic forwarding. So for this, we will continue to leverage Nexus Dashboard either via the user interface or the northbound API. You also have the NX API and NX CLI for direct device configuration for Nexus devices. From a security operations perspective, we're managing security policy configuration and distribution of that policy. For this, we will leverage the on-prem controller with or without security cloud control. So initially, security cloud control was going to be the only management component available because I guess like similar to Intersight, we felt this was the direction that most customers want to head with their management tools. They don't want to have to manage their management tools or upkeep their management tools. However, customer feedback was the opposite of our expectations, so we've now updated the architecture to include the on-prem controllers. These will be a required component of the architecture, but they will be a cluster of VMs deployed on-prem, meaning that there isn't going to be any new hardware costs, right? And they will be licensed via a Hypershield license. So centralized policy configuration, testing and validation, approval, and then deployment will all be coordinated through the on-prem controllers or security cloud control. Nexus Dashboard and Security Cloud Control are going to share context information with each other. And what that does is it enables the NetOps and SecOps team with enough respective visibility. So basically, it allows the network team to see some information at a security layer, and it allows the security team to see information at a network layer so that they can determine whether the issue is network or security related and who needs to own the fix to a problem that's encountered. This is to help avoid finger pointing and enable better collaboration between the teams that have related but separate responsibilities. From a cost saving standpoint, as I mentioned, Hypershield on-prem controller will be a cluster of VMs, enabling you to take advantage of existing hardware capacity without any new hardware purchases. And then deploying the controller cluster will be enabled through Hypershield licensing, as I already stated. All right, automation and programmability. This is handled by the devices and their management platforms. So we already talked about Nexus Dashboard, its UI and northbound API, as well as NX API and NX CLI on the previous slide. On this slide, we're going to cover the Hypershield management options. So on the left, we have an air-gapped deployment consisting of only the Hypershield on-prem controller VM cluster. The cluster provides the configuration user interface as well as a northbound API for automation and programmability purposes. The primary downside to this deployment model is the need to separately configure each air-gapped site. On the right, we have a customer who has opted to leverage Security Cloud Control with the Hypershield on-prem controller VM cluster. In this case, Security Cloud Control will make API calls to the on-prem controller's northbound API to achieve configuration rather than being accessed directly or via DevOps tools. And Security Cloud Control will have its own northbound API for automation and programmability purposes. The primary upside to this deployment model is centralized configuration and deployment for all locations. Okay, so the key here was, we had some important customers that had air-gapped deployment requirements, and so we needed to have an on-prem controller capability. This is how we have now built this into our architecture. I don't know that this slide represents what we tend to think of when we hear the word automation, things like DevOps tools and APIs and such, but to me, this is still a component of automation. It's like CI/CD in the development world, but applied to the problem of changing security policy on a live network. Our smart switches use dual data planes, which we're showing in this slide as the yellow text that says digital twins. AI may provide security policy recommendations, or you can configure security policies on your own, but customers often avoid deploying or even removing security policy out of fear that they're going to break something. So, to get around this, our production data plane makes a copy of production traffic and sends it to the test data plane, which we're showing in the yellow box. This is where policy validation takes place before the policy ever enters production. That way, we can proactively determine if introducing or removing the policy breaks anything. Once we have confidence, we can then move to deployment. So we have built-in workflows to take you through the policy design, security review, change request, and even the business approval. And not only that, but we can also do canary rollouts so that we're not deploying the policy to every device in your network at the same time. This just provides an additional precaution that customers can take when dealing with sensitive security policy changes. All right, comprehensive management and visibility. I think this is probably the best slide to convince you of comprehensive management and visibility. We already talked about NetOps and SecOps tools, including Nexus dashboards, security cloud control, and the on-prem controller clusters, all shown in yellow boxes on this slide. These all provide user interfaces, which themselves provide environment visibility. But in addition to these tools, all our telemetry data from network, NIC, and host or workload layers can be exported to Splunk and Grafana UI for even more visibility and diagnostics. Also, another important distinction that this slide makes is that for modern cloud native or container-based applications, software agents running on workloads can also be deployed on a Kubernetes cluster in the public cloud. In that case, workloads are container or process-based with software agents running on the workloads, so only security cloud control would apply in that case. Nexus dashboard and obviously the on-prem controller would be irrelevant. Okay, so in terms of use cases, I didn't have a good visual for this, so I just kind of typed this up. There's multiple use cases that we should be thinking about and considering when talking to customers and trying to position Smart Switch. So first, we've talked about future proofing and modernizing data center infrastructure. So if your customer is a greenfield customer, if your customer has LDOS equipment that they're looking to refresh because it's at the end of its hardware lifecycle, these are opportunities for both future proofing and modernizing the data center infrastructure. We support multiple different types of fabric atop smart switches, including VXLAN EVPN, multi-site VXLAN EVPN, BGP routed, and classic LAN fabrics. Any features that aren't available in NXOS today are going to be available in the next 1 to 2 software releases according to the business unit. Now, we've also got smart switch network and security use case. So whereas the first bullet point, future proofing, is about the DPU being disabled, in the case of network and security use case, that's when the DPU becomes enabled. This is what's going to give us top of rack layer 4 segmentation capability. This is currently in controlled availability and testing today, i.e. December and January. I mentioned today's January 5th, with general availability expected in the spring. Okay, so probably in Q3 fiscal year 26. We can also use smart switches to secure your AI networking fabrics. Smart switch is applicable for front-end networks and is compatible with AI pods. And then I mentioned before that we have upcoming use cases. Cloud edge is where we would have a firewall sandwich. This is typically expensive to provide and it's slow. And we feel that smart switches here are going to provide approximately a 60 to 80% TCO reduction. And an example of a place where this may be used would be something like a large bank. Then we have zone segmentation. This is primarily done for performance gain, which is typically a NetOps decision, and it's applicable in both production, development, and campus networks. And then secure peering for data center interconnect. Example of this would be border gateway or high bandwidth applications requiring basic layer 4 blocking and tackling. And then finally, we have converged infrastructure portfolio. So smart switches are appropriate top of rack switches within our ZI solutions. We've got FlexPod, we've got FlashStack, we've got Hitachi. All of these are CVD backed solutions. And we also have virtualization and container solutions. We have newer CVDs that apply to vSphere 4 and Red Hat OpenShift 4.20 that are available today. So all of these are applicable use cases for positioning smart switch. Now, in terms of partner enablement, I want to first make sure that you understand the competitive differentiation. So I'm not going to read all of these bullet points to you. I want to leave them here. I want you to read this slide in detail. But to me, what this boils down to is together, Hypershield and Smart Switch are a single vendor integrated solution with scalable performance, distributed inline policy enforcement, comprehensive visibility, and a single vendor support model versus the alternative, right? Which is a combination of solutions from maybe multiple vendors. You've got more complex traffic routing and therefore inefficient use of network bandwidth. You've got centralized policy enforcement, so you don't have that distributed scale that you can get with each top of rack switch, and a multi-vendor support model. When a security breach occurs, a multi-vendor support model just leaves the customer with vendors pointing the finger at each other, while a single support model with an integrated solution ensures that you're going to have a better end-to-end experience. Okay, I've collected a short list of resources that are available for partner enablement. There's probably additional ones that I need to dig up, but for starters, you've got the Smart Switch landing page on Cisco.com. You've got the Smart Switch data sheet and FAQ. There is an at a glance available that talks about Smart Switch with Hypershield. There's also a blog article that was written by members of the BU that are supporting this product. And then there's a partner success webinar that was held back in July. So this is a little bit dated, and I'm pretty sure we have newer content available, or it's going to be coming available most likely in January. So stay tuned for additional emails from me talking about additional partner enablement opportunities. Now, for licensing and promotions, licensing here is pretty simple. I've just captured a few notes on the left in yellow. So first, you must have a premier level license to turn on the DPU in the switch. And then on top of having the DPU enabled, you're also going to need a Hypershield license, which can be sold through Cloud Protection Suite. And then the license is flexible, right? So it can be used for Tetration, Hypershield, Smart Switch, etc. Okay. And then networking and security are transacted separately. This works with both EAs and WPAs. And then from a promotion standpoint, this is the promotion that we currently have running. It went live on November 30th. It's going to end at the end of Q3 fiscal year 26, which means end of April for Cisco. There's no guarantee that this promotion is going to be extended into Q4. We simply don't know. The BU is not talking about that. So at the bottom in green, bottom left, you'll see the major line bundle SKU that you can use for this promotion. There's no volume limits in terms of the number of switches that you can purchase. This will be for the 25 gig top of rack smart switch, not the 100 gig switch. So as it says here on the slide, you've got 48 ports of 25 gig. You've got a couple of different 100 gig and 400 gig uplink options, 100 gigs of services throughput, meaning throughput through the DPU. which really is faster than any of what our competition is offering right now. And this promotion is offering the same list price as the 93180YC FX3, which is one of our most popular Nexus 9000 switches, access layer switches. And that happens to be 19% lower list price than the 93240YC FX2. Both of these switches are 48 port 25 gig switches, right? So we feel that this is a very good price, especially for the performance that you're getting out of it, as well as the integrated security architecture. And then the Premier license that you'll need to enable the DPU is also going to be discounted to be the same list price as the DCN Advantage license through the end of April. Okay, I didn't really have, I don't know, a slide header title for this, but from a positioning standpoint, I mentioned, greenfield customers, so there's no existing switch to be replaced, but also LDOS customers. So if you've got LDOS customers or customers looking to refresh their existing network hardware, then this slide provides a mapping of, on the left, you've got the 25 gig smart switch is a good replacement for these existing switches. And over on the right, you've got the 100 gigs smart switch, which is a good replacement for these existing switches. Okay, so just should help you out from a positioning perspective. And then I mentioned I wanted to wrap up by reviewing the overall value proposition of Smart Switch. So first, we've got future-proofing infrastructure. We have an opportunity today for customers buying greenfield or for those looking to refresh LDOS equipment to position Smart Switch. Unlike existing switches, Smart Switches have DPUs inside of them. Initially, the DPUs will be disabled until Hypershield is fully ready. When ready, the DPUs can be enabled, unlocking security policy enforcement capabilities within the DPU. So think about the security policy enforcement layers that we've talked about. Network is available today via the Smart Switch. NIC may be available via Smart NIC DPUs in the future. And host is available today via the software agent on Linux and will be available with Windows in the future. Smart Switch addresses security at the network layer for those who can't enforce at more specific NIC and host layers. If customers don't purchase those DPU capable switches today, then we may not capture that business until customers complete another entire hardware refresh cycle, up to 5 to 7 years. And that also means that customers are going to miss out on a new multi-layered approach to security, leaving them vulnerable for that time. If we help customers purchase DPU capable switches today, then they're protected for that same 5 to 7 years, and we can enable new capabilities as they come online. And that means that the customer doesn't have to scrap existing hardware investments to achieve new capabilities in software. And remember that the DPU is a programmable chip, meaning that its functionality is only going to continue to be enhanced. Okay. Second, we've got attack surface reduction. Smart Switch will provide layer 4 east-west distributed security policy enforcement to prevent lateral spread of attacks within the data center. Smart Switch is also part of the Hypershield security policy enforcement ecosystem, which will help protect against exploits within hours instead of weeks. Then we've got firewalled offload economics. Today, customers who want to secure their network traffic are forced to purchase very high throughput and very high cost next generation firewalls like Palo Alto. With Smart Switch, you're getting a top of rack switch with 800 gig line rate throughput per switch at the top of every rack if that's what your customer requires. Smart switches are faster than the top of line firewalls in terms of throughput, and they provide scale out performance as your network grows rather than potentially tapping out throughput on your very expensive firewalls. Smart switches also provide distributed security policy enforcement at the top of every rack. rather than centralizing enforcement through a single pair of devices. That means your security policy is closer to the workload. So from a network traffic forwarding perspective, you're being more efficient, right? And then compliance readiness. Having a distributed top of rack architecture eliminates blind spots in your east west traffic, along with obviously the additional telemetry that we're going to be getting from NICs and from software agents on our workloads. This is highly suitable for meeting compliance requirements in PCI and other similar types of regulated environments. Please see my notes in yellow at the top. As a distributed architecture, it enables us to minimize the blast radius of an attack. If you can't deploy workload layer protection on the host, that's okay. Step back to network layer protection, or you can do both. We have a better, faster, cheaper product than our competitors. An 800 gig firewall alternative from Palo Alto is 500K plus, and that's for a single firewall. So for a pair of high throughput next gen firewalls, you're looking at it over $1 million. Or you could leverage multiple inexpensive firewalls with routing that increases your complexity. So only Cisco is providing unified policy and visibility using a combination of enforcement points, including DPU-enabled Nexus Smart Switch at the network layer and eBPF software agents at the workload layer today, both with policy centrally configured within Hypershield and pushed to the desired enforcement points. And with that, I hope this presentation helped you understand what Cisco is aiming to achieve for customers with Smart Switch and how. Please learn this messaging and position Smart Switch this year. With Hypershield coming out soon, I think this is going to be a big win for customers and for partners. If you have any questions, feel free to reach out. Thanks for taking time to watch this presentation. Cheers.